Hi, my name is Emara Rangel, and I'm going to talk about the historical role of animals in the emergence or maintenance of zoonoses. In my presentation, I'm going to talk about zoonoses. I'm gonna talk about what they are and how can they be transmitted. I'm also going to talk about emerging infectious diseases, what they are and which are their determinant factors, and about the One Health approach, its definition, and some historical events that are important to know so we can understand how zoonoses have happened and how have they been managed. As introduction, by studying surveillance and methods to control zoonoses in the distant past, the history of fighting these diseases can be traced. The analysis of historical events provides a series of lessons on the positive and negative effects of past theories on the etiology, transmission, and control of diseases. These lessons serve as a reminder of the urgent need for extensive research on zoonoses and the need for opportune application of these findings to disease control activities. So, what are zoonoses? First of all, I'm going to talk about Rudolf Virchow. He was a German pathologist who became interested in the linkages between human and veterinary medicine while studying a roundworm, Trichinella spiralis, in swine in the 19th century. He established the term zoonosis to name an infectious disease that is passed between humans and animals. He also emphasized that between animal and human medicine there are no dividing lines, nor should there be. The object is different, but the experience obtained constitutes the basis of all medicine. Throughout history, humans have been affected by zoonoses. And these diseases can be acquired directly by contact between the infected and susceptible individual. This can be done through bites or by handling infected tissues or animal materials. Or this can be done indirectly by vectors, which are agents which carries and transmits infectious pathogens into another living organism. Fomites can also be an indirect way to acquire a disease. These are inanimated objects capable of carrying infectious agents, and contaminated food can be another way. Cross-species transmission, or spillover, is the ability for a foreign virus, once introduced into an individual of a population, to complete the virus infectious cycle. This means that when a virus is just affecting one kind of species, sometimes they can jump to another new species, and then it can cause or not cause disease on this new host. If it does, then sometimes it can also jump to, be transmitted between this new host and species, or it can just remain in the new infected individual and die there. Emerging infectious diseases. Emerging infectious diseases are serious public health threats globally. An emerging infectious disease is one that either has appeared and affected a population for the first time, or has existed previously but is rapidly spreading, either in terms of the number of people getting infected or to new geographical areas. Many emerging infectious diseases are zoonotic in origin, which means that the disease has emerged from an animal and crossed the species barrier to infect humans. In recent years, a number of new zoonoses have emerged in both developing and developed countries, and a number of known zoonoses have re-emerged in areas where they had been absent for decades or have spread to animal species in which the pathogens had not previously been detected, which is the so-called spillover. Some determinants that contribute to the emergence of new zoonotic agents are ecological changes, which include economic development and land use, human demographics, and the behavior of people, international travel and commerce, technology and industry, microbial adaptation and change, and breakdown in public health measures. Now I'm going to explain each of them and give some examples. Ecological changes include those to agricultural or economic development and are among the most frequently identified factors in emergence. They are especially frequent as factors in outbreaks of previously unrecognized diseases with high case fatality rates, which often turn out to be zoonotic introductions. Some examples include agriculture, dams, changes in water ecosystems, deforestation and reforestation, flood and drought, famine, and climate changes. One example is the emergence of Lyme disease in the United States that was probably due to reforestation, which increased the population of deer and the deer tick, which is the vector of the Lyme disease. And then the movement of people into these areas placed a larger population in close proximity to the vector, which is this might be the reason why there was a disease outbreak. Human demographics. Human demographics include societal events like population growth and migration, which is movement from rural areas to cities, war or civil conflict, urban decay, sexual behavior, intravenous drug use, and use of high-density facilities. One example of this factor is the frequency of the most severe form, dengue hemorrhagic fever, which is thought to occur when a person is sequentially infected by 2 types of dengue virus, is increasing as different dengue viruses have extended their range and now overlap. Dengue hemorrhagic fever is now common in some cities in Asia, where the high prevalence of infection is attributed to the proliferation of open containers needed for water storage, which also provide breeding grounds for the mosquito vector. As the population size exceeds the infrastructure. In urban environments, rain-filled tires or plastic bottles are often breeding grounds of choice for mosquito vectors. The resulting mosquito population boom is complemented by the high human population density in such situations, increasing the chances of stable transmission cycles between infected and susceptible persons. The next factor is international travel and commerce, which includes worldwide movement of goods and people by air travel. Principle. And one example of this factor is yellow fever, that at the beginning in the 16th and 17th centuries, ships bringing slaves from West Africa to New World also brought this disease and its mosquito vector, Aedes aegypti, to the new territories. So, yellow fever is an acute viral hemorrhagic disease transmitted by infected mosquitoes. The yellow in the name refers to the jaundice that affects some patients. Symptoms of yellow fever include fever, headache, jaundice, muscle pain, nausea, vomiting, and fatigue. A small proportion of patients who contract the virus develop severe symptoms, and approximately half of those die within 7 to 10 days. The virus is endemic in tropical areas of Africa and Central and South America. Large epidemics of yellow fever occur when infected people introduce the virus into heavily populated areas with high mosquito density and where most people have little or no immunity due to lack of vaccination. In these conditions, infected mosquitoes of the Aedes aegypti species transmit the virus from person to person. Yellow fever is prevented by an extremely effective vaccine, which is safe and affordable. A single dose of yellow fever vaccine is sufficient to confer sustained immunity and lifelong protection against yellow fever disease. Good supportive treatment in hospitals improves survival rates. There is currently no specific antiviral drug for yellow fever. To eliminate this disease, there has been some strategies launched in the past years. The aim of this is to protect the at-risk population and prevent international spread of the disease, and to contain outbreaks rapidly. So it's expected that in about 7 years, the disease, more people will be protected against the disease. Another factor is technology and industry, which involves high volume rapid movement characterizes not only travel, but also other industries in modern society. In operations, including food production that process or use products of biological origin, modern production methods will increase efficiency and reduce cost, but can increase the chances of accidental contamination and amplify the effects of such contamination. The problem is further compounded by globalization, allowing the opportunity to introduce agents from far away. An example of this is E. coli, which is a pathogen present in some of the raw material that has found its way into a large batch of final product, such as hamburger meat. This disease causes hemolytic uremic syndrome. In the United States, there's a strain that has been found, but it is spread along many countries. Some more information about E. coli. This is a bacteria that is commonly found in the lower intestine of warm-blooded organisms. Most E. coli strains are harmless, but some can cause serious food poisoning. Shiga toxin-producing E. coli is a bacterium that can cause severe foodborne disease. Primary sources of the toxin outbreaks are raw or undercooked ground meat products, raw milk, and fecal contamination of vegetables. In most cases, the illness is self-limiting, but it may lead to a life-threatening disease, including hemolytic uremic syndrome, especially in young children and the elderly. The toxin is heat sensitive, so in preparing food at home, it's good to be sure that basic food hygiene practices are done, and that meat is cooked, is well cooked. Another factor is microbial adaptation and changes. I'm going to talk about this on the next section.